Rectilinear motion. Anti-differentiation is particularly useful in analyzing the motion of an object moving in a straight line. Recall that if the object has a position function s which is equal to f of t, then the velocity function is v of t which is equal to s prime of t. This means the position function is an antiderivative of the velocity function. Likewise, the acceleration function is a of t which is equal to v prime of t. So the velocity function is an antiderivative of the acceleration. If the acceleration and the initial values of s of 0 and v of 0 are known, then the position function can be found by anti-differentiating twice. So for example 5, we want to finding the position given acceleration. A particle moves in a straight line and has acceleration given by a of t, which is equal to 6t plus 4. Its initial velocity is v of 0, which is equal to negative 6 centimeters per second, and its initial displacement is s of 0, which is equal to 9 centimeters. We want to find its position function s of t. So, first thing is first, we know what the acceleration function it's given. And the acceleration function it's given is the following. We know that the acceleration function a of t is going to equal 6t plus 4. Okay, and now we know that the antiderivative of that function is going to be the velocity function. So if we want to find the antiderivative of this function, v of t, well, we know it's going to be 6 to the t to the 1 plus 1, which is 2, over 2. And that's going to be plus 4t. Okay, and then we have to add that constant c. And so if we want to simplify that a little further, the velocity function is going to be 3t squared plus 4t plus c. Okay. Now, what else do we know about this? Well, we know that that the initial velocity is v of 0, which is equal to negative 6 centimeters per second. So we know that v of 0 is going to equal negative 6. So we're going to plug it into the velocity function to be able to find out what c is. So we know v of t is going to equal negative 6, and we know that t is going to be 0. So it's 3 times 0 squared plus 4 times 0 plus c. So therefore, we know that c is going to equal negative 6 since both of those are going to be 0. So what does that tell us about the velocity function? Well, it tells us that the velocity function is going to be the following. That means that v of t is now going to equal 3t squared plus 4t, and that's minus 6. Okay? So now what we want to do is we want to be able to then find the position function. So let's find the antiderivative of step number 4. So the antiderivative is going to give us the position function s of t. So the antiderivative of 3t squared is going to be 3 to the t, that's 2 plus 1, which is 3, over 3, plus 4t to the 1 plus 1, which is 2, over 2, minus 6t, and then we have another constant, and we're going to call that d because that's the constant for the position function. So let's simplify this a little further. So s of t is now going to equal t cubed plus 2t squared minus 6t plus d. Okay, so now what do we know? Well, we know that the initial displacement has the following. We know that s of 0 is equal to 9, and so we're looking for the constant d. So s of t is going to equal 9, and we know that 0 is going to be the value of t. So 0 cubed plus 2 times 0 squared minus 6 times 0 plus d. So therefore, those all become 0, and so we know that d is going to equal 9. So therefore, we can say that the position function is the following. S of t is going to equal t cubed plus 2t squared minus 6t, and that's plus 9. And so therefore that is the position function.